Yes, hello friends, this is the continuation. This I am solving classroom workbook questions based on types of choppers, types of choppers based on commutation methods, SMPS and multiphase choppers. Based on this, we are solving the questions. Think in the last session I discussed up to question number 8. Yes, this is completed. Then we'll start with question number 9. See the question. This is a given circuit. Inductance is 20 microhenry. Yes, this thyristor. Capacitance is 50 microfarad. Is 600 volts. Is thyristor. Okay. Given that the initial voltage across the capacitor is 0, then the initial current in the inductor is 350 amperes. Okay. Initial current in the inductor is 350 amperes. This is Vc of 0 and this is IL of 0. Then first one is to find the current I. In this circuit, you find the current I. Okay. What is question number A? I equal to IP into sine omega t plus theta. Yes. Then if you want to find I means you know what is the IP value and what is theta value. Okay. Then for this circuit, if only initial current in the inductor is known, once there is no initial voltage across the capacitor, I give an expression for how to calculate peak current. The value of peak current equal to this formula I given, square root of VDC square into C by L plus I naught square. This formula I given. Then what is the peak current equal to square root of VDC 600 square into what is the capacitance value 50 microfarad, what is the inductance value 20 microhenry plus 350 square. Then by simplifying this, the peak current equal to how much you get? 1011.12 amperes. This is the peak current. Then I want to find what is the theta value. This also I given tan inverse. How to calculate theta? I naught by VDC into square root of L by C I given. Therefore tan inverse I naught 350, VDC how much? 600 into square root of L is how much? 20 microhenry. How much C? Is 50 microfarad into 50 into 10 power minus 6. Then from this, what is the theta you can calculate? We get 20.25 degrees. Then once you know the theta, then what is I equal to? I equal to 1011.12 sine of omega t plus 20.25 degrees. Yes. Okay, this is current I in the circuit. But the question number B, what it is given? What is the on period of the thyristor? What is the on period of the thyristor? T on equal to pi minus theta by omega. If theta is 0, that I given in LC circuit pi root LC. But here theta is exists because there is initial current in the inductor. If the initial current in the inductor is 0, there is no theta. Theta you take the 0. Then you can get what is T on pi by omega, where pi minus theta by omega naught, where omega naught is that you calculated 1 by root LC. Okay. Then pi minus theta is how much? 20.25 into, I want to tell in terms of radians, pi by 180, omega naught is 1 by root LC. Then what is the on time of, this is on time of thyristor, T on. This on time of thyristor. Then what is T on equal to pi minus 20.25 into pi by 180 by 1 by root LC. L is how much? 20 microhenry. C is how much? 50 microfarad. Then you simplify this, we can get T on equal to 88.16 microseconds. This is on time of the thyristor. If it is not there, pi root LC that I told, theta is 0. Okay. Then what is the C question? What is the peak voltage across the capacitor? VCP. This formula also I given in the analysis. The peak voltage across the capacitor equal to, okay, this analysis also I given. How to calculate? If there is no initial voltage across the capacitor, the peak voltage across the capacitor, if the initial current is given, what I given? VDC plus square root of, this formula already given in the analysis, I naught square into L by C plus VDC square. Then what is VDC? 600 plus square root of, I naught is how much? 350 square into L is 20 microhenry, C is 50 microfarad plus how much? VDC square? 600 square. Then you get 1239 volts. This is the peak voltage across the capacitor. Okay, this is one model of question. Okay, that you concentrate. Quick, no doubt. You can expect like this also. Okay, all this, sir, how we are getting this formula? All this analysis already given. What is peak current? What is the value of theta? Okay, once you know the theta, how to calculate on time? Okay, C question is what is the peak voltage across the capacitor? See the question number 10. Yes. For the circuit shown in figure, Vs is 200 volts. Next, what is R1 is given? 10 ohms. Yes. What is R2 is given? 100 ohms. What is the given circuit, you tell me? Yes, given circuit is, this is a circuit given, this is R1 and this is R2. This is T1 thyristor and this is T2 thyristor. This Vs. Okay, in this circuit, peak value of current through thyristor T1 and T2. This is which circuit? Classic commutation. Already given the formulas. A question. Peak current through T1 and T2. IT1P equal to Vs into S. 1 by R1 plus 2 by R2. That is Vs is how much? 200. 1 by how much? R1 is given 10 ohms plus 2 by R2, 2 by 100. Then what is the peak current through the T1 thyristor? How much you get? Yes, the peak current through the T1 thyristor is 24 amperes we can get. What is I2 to P? Peak current through the T2 thyristor. Vs into 2 by R1 plus 1 by R2. That is 200 into 2 by 10 plus 1 by 100. Then how much we get? This we can get 42 amperes. This is the A question. What the B question? It is asked that you concentrate. Yes. Value of capacitor C if each thyristor has turn off time of 40 microseconds. Take a factor of safety equal to 2. If each thyristor is having turn off time of 40 microseconds and take the factor of safety is 2, then what is the each thyristor turn off time? Tc1 equal to each thyristor turn off time. Each thyristor turn off time is given, that is 40 microseconds. But what is the circuit turn off time? Safety factor into device turn off time. Then how much we can get? 80 microseconds. 80 microseconds. Then how much? What is Tc1 equal to R1C into ln of 2. Now from this, what is C equal to? R1C1 into ln of 2. Or C is same for both. Then what is C equal to? Tc1 by R1 into ln of 2. Yes, what is Tc1? 80 microseconds. R1 is how much it is given? 10 ln of 2. Then you get the value of C equal to 11.542 microfarad. How much you get? 11.542 microfarad. Now if you take with respect to T2 thyristor, what is Tc2 equal to R2C into ln of 2. Then Tc2 also 2 into 40 microseconds. This is how much? 80 microseconds. Okay. Then from this, what is C equal to? 80 into 10 power minus 6 by R2 is how much? 100 into ln of 2. Yes. Then what is C equal to? We can get 1.542 microfarad. That is 1542 microfarad. We are getting 1.1542 microfarad, 11.542 microfarad. Then always, if you want to make the turn off of this thyristor, T2 thyristor, this is required. To make turn off of this thyristor, this is required. If you select this one, this thyristor will not be turn off. If you select C equal to 1.15 microfarad, then this thyristor will not be turn off. Then if you select 11.542 microfarad, this thyristor will be, T2 thyristor will be turn off. That's why you select the high value. Therefore, the value of C equal to, for effectively turn off of both the thyristors, 11.542 microfarad. And this is the value. Both are given, that you take. But for with respect to this thyristor, but when this which select means high value you can select. Because when I take only this one, but to turn off this thyristor, this is required. Okay, but is it can turn off this one? No. But to turn off T2 thyristor, this is 1.15 is. If 1.15 is enough means 11.542 also will be turn off. For this capacitance also it will be turn off. That's why you take the high value for effectively turn off of both the thyristors. That's why 11.542 microfarad is the best selection. Clear? Concentrate. If R1 equal to R2 equal to R is given, we can get only one value of C only. But here different values of R1 and R2 is given. That's why you are getting two values of capacitance. In that, which is the best selection means you take the high value in order to turn off both the thyristor. If you take low value, high value, the thyristor which requires high value of capacitance, that will not be turned off. Okay, concentrate. This question number 10. For a voltage or impulse commutated thyristor circuit shown in figure, capacitor is initially charged to Vs with polarity as shown. Find the circuit turn-off time for the main thyristor in case C equal 10 microfarad, R equal to 5 ohms and Vs equal to 200 volts DC. Okay, this is the given circuit. This is T1 thyristor. This T2 auxiliary thyristor. This is the resistance. The supply voltage is 200 volts. This is the resistance. C value is, this is Vs minus plus. This is auxiliary thyristor. This is 200 volts it is given. Okay. Then what the data is given? C equal to 10 microfarad. R equal to 5 ohms. Then you find circuit turn-off time of main thyristor. To find the circuit turn-off time of main thyristor. If you take this is voltage commutation circuit means one formula for circuit turn-off time Tc equal to CVS by I naught. Then how to calculate I naught equal to V naught by R. Okay. Then what is V naught, you tell me? That is V naught equal to D dash into Vs. What is D dash? T on dash by T into Vs. But the data is not given to calculate T value. Regarding to, is there any data is given? No. Is there any frequency of operation is given? Not. It is not given. That's why we don't follow this, we don't apply this formula, because the data is insufficient to apply this formula. But if you analyze this circuit also, then when the thyristor will be turned off, whenever auxiliary thyristor is triggered, it will be turned off. Then it's just like a RC circuit. Okay. Then it's just like across two thyristors, there is a capacitor. Na? In the previous problem I given, across two thyristors, this is capacitor, here we are connecting two thyristors. In this case, what is circuit turn-off time we calculated? If you want, that means apply the KVL, then you get the same answer also. But no need of that, simply remember like this. It's just like two thyristors with one capacitor. Okay, then what is circuit turn-off time? Tc equal to RC into ln of 2, this you know. Then R is how much it is given? 5 ohms. C is how much it is given? 10 microfarad. 10 microfarad. 10 into 10 power minus 6. ln of 2, this value is 0.693. Then you simplify this. What is circuit turn-off time? We can get 34.65 microseconds. 35.66 microseconds we can get. This is the value of circuit turn-off time. Okay, clear. This is ln of the exact value also you substitute. Approximate is 0.693. You take that in calculator, then you simplify this, we can get 35.66 microseconds. See, again no need to make any derivation. Simply remember, it's just like two thyristors. In the class C commutation also, two thyristors with one capacitor. Na? Here also two thyristors with one capacitor. Then you can get the 35.66 microseconds. But the exact voltage commutation circuit is also consists of inductor, all this. But inductor is not given here. Then you take, this is similar to that of what? Class C commutation. It is mentioned that it is impulse commutation. No doubt at all. Okay, that's the self commutation, 35.66 microseconds. Understood? Okay, if inductance is given, based on that inductance, the circuit turn-off time will be changes. Clear? So this is about question number 11. 35.66 microseconds we can get. This is the given circuit. This thyristor. The resistance is 100 ohms. 100 ohms. Inductance is 5 millihenry. Inductance is 5 millihenry. Capacitance is 1 microfarad. Capacitance is 1 microfarad. The supply voltage is 300 volts. The supply voltage is 300 volts. Okay. Then you calculate what is the conduction time of thyristor. In this circuit, the conduction time of thyristor is I given pi by omega. Pi by omega. Then pi by omega. What is omega? This is RLC circuit now. Square root of 1 by LC minus R square by 4L square. This formula you know. Okay. You substitute all these values. Omega equal to L you know, C you know, then R is also you know, then you can get 10,000 radians per second you can get. Then what is conduction time of thyristor? Conduction time of thyristor is 3.14 by 10,000. Then how much we can get? 0.314 milliseconds. Simple question. But this is LC circuit na, RLC circuit na, you remember this formula. Okay, 1 by LC. If it is only LC circuit means R is 0. Then what is omega? 1 by root LC. But it is 1 by LC minus R square by 4L square. Clear? Concentrate. This question number 12. Yes, quick note down. Yes. See the question number 12. Sir, question number 13. This question number 13. 12 is already over. This question number 13. In push-pull type DC to DC converter, the output voltage V0 is given by dash. In push-pull type, option A, what it is given? 2 into N2 by N1 Vd into T on by T on plus T off. Okay. Option B is given, that is N2 by N1 into Vd, that is T on by T on plus T off. T on plus T off. What is option C? It is given 2 into N2 by N1 V0, sorry, VDC into T on by T off. Option D, N2 by N1 into Vd T on by T off. It is asked what is in a push-pull converter, what is the average output voltage? You know that I already given the average output voltage equal to 2 into VDC, that is 2 VDC, that is 2 into N2 by N1 into dVDC I given. This formula I given for push-pull converter. Okay. Then what is 2 into N2 by N1 into what is VDC? You write on time by total time period. On time plus off time into VDC. Then which option is correct? That is 2 into N2 by N1 into VDC into T on by T on plus T off. Option A is correct. What is V0 is given? 24 volts. Question number 14. V0 equal to 24 volts. Okay. Then duty cycle equal to 0.5. 0.5. Load resistance is 2 ohms. N2 by N1 equal to then 0.25. 0.25. Then calculate average source current, average switch current. First one is you want to calculate average source current. A V0 is given as 24 volts, N2 by N1 equal to 0.25. Then you know this, instead of first you calculate, before calculating average switch current, right, it is average source current. Then first you calculate what is V0 equal to 2 into N2 by N1 into dVs. This is V0, you know. Then what is V0? 24 volts. 2 into what is N2 by N1? 0.25. Duty cycle is how much it is? 0.5 into Vs. From this, what is the supply voltage we can get? You tell me. Supply voltage equal to, yes, how much you can get? Simplifying that, how much supply voltage we can get? 96 volts we can get. Okay. Then what is the first question? You want to calculate average source current. To calculate average source current, assume that it is a lossless. Input power equal to output power. This you know. Input power equal to output power. Then what is I0 equal to? I0 equal to V0 by R. What is V0? Is given 24. What the resistance is given to? 12 amperes. What is Vs? Vs is 96 into Is. Then what is V0? V0 is how much? 24. What is I0? 12. Then from this, what is Is equal to? Then we get average switch current, source current equal to 3 amperes we can get. This is the average source current. This is the first question. Average source current. Okay. Then what the second one? Average switch current. Average switch current equal to. But the switch will conduct only on time only. It will not conduct off time. Then half of that only it will conduct. Then what is average switch current? Yes. Average switch current equal to. The average switch current equal to Is by 2 we can get. Then how much we get? 1.5 amperes. Okay. Next, peak switch current equal to source current. What is the peak switch current? Peak switch current is nothing but that is a source current. This is how much it is. You are getting 3 amperes. What is the, that is the average switch current. Peak switch current equal to source current. What is the average switch current? Average switch current is how much? 1.5 amperes. Okay. Then what it is asked? What is the RMS switch current? RMS switch current. RMS switch current equal to Is by root 2 only. This how much? 3 by root 2 amperes. Then what is the equation it is asked? Open circuit voltage across the switch. The open circuit voltage across the switch is, okay, 2 times it will appear. This is center tapped arrangement na. That's why open circuit voltage across the switch. That is the peak voltage across the switch. Peak voltage across the switch. Open circuit voltage across the switch is nothing but 2 Vs. This is a center tapped arrangement. Vs is how much it is given? 24. That is 48 volts. Understand? This is not a quick. Yes. Read the question. For the circuit shown in figure, the switching frequency is 1 kHz. Assuming both the switches are equal current sharing, then the average value of switch S1 is dash. Okay, this is the given circuit. This is a question number 15. This is the given circuit. This is 100 volts. Okay. Let this switch S1. This given that inductor, this capacitor, and this is resistance. Okay. This resistance is 1 ohm. And this is diode is connected like this. Okay. Then another switch is connected like this. Okay, this is inductor. This is S2 switch. This is S1 switch. And diode is connected like this. And this is L. This also L. The switching times also given like this. This S1 switching. This is S2 switching. This how much? 0.5 milliseconds it is given. And this is 1 milliseconds it is. Okay. Then you find what is the average value of switch S1, IS1 average that you want to calculate. It just like this is which converter? Buck regulator. This also one buck regulator. It just like two buck regulators is in parallel. Na? This is multi-phase chopper. Okay. But listen please. Even though two choppers or two regulators are connected in parallel connection resultant voltage remains same. Then first I want to calculate what is V0. What is V0 equal to dVs? V0 equal to dVs. If V0 equal to dVs means, tell me, then what is the duty cycle? To calculate duty cycle, you apply on time by total time period. For this, you take the switching instance. What is the on time? It is given 0.5 milliseconds. On time is 0.5 milliseconds. By total time period is 1 millisecond. Then how much you get? 0.5. Then what is V0 equal to 0.5 into 100? This how much you can get? 100 volts. V0 equal to 100 volts. The voltage across the load is, the voltage across the load is 50 volts. This is 50 volts. This is 50 volts. If it is 50 volts means, what this current you tell me? 50 amperes. That is 50 amperes. That is I0 equal to V0 by R na? How much you can get? I0 equal to V0 by R means 50 by 1. This we can get 50 amperes. But you want to find what is the average value of switch current. Average value of switch current. For that, first you tell me. Let's assume that for lossless chopper. What is the condition for lossless chopper? You tell me. Input power equal to output power. For a lossless chopper, input power equal to output power. What is the input power? That is Vs into Is equal to V0 into I0. Okay. What is Vs? 100. Is I want to calculate. What is V0? V0 equal to dVs, that you calculated 50. What is I0? I0 is how much we are getting? 50. Then what is Is we can get? This is we can get 25 amperes. The average source current. This is the average source current. Average source current. Okay, average source. That is the average source current equal to how much? The average source current is 25 amperes. But you want what is the average value of IS1? The average value of IS2. Okay, but it is equally sharing. Load sharing is given as equally load sharing. Equally load sharing means then what you can get, average value of source current switch current equal to, this is how much we can get, 12.5 amperes. This also how much we can get, 12.5 amperes. Therefore the average value of switch current equal to IS1 average equal to 12.5 amperes. Understand? Okay, this we can solve the problem. Or you also solve, we know that in the case of this is what is the load current we are getting, 50 amperes. We are getting load current is 50 amperes now. If it is 50 amperes means this will supply how much current, 12.5. This also supplies how much, sorry, this supplies how much current, 25 amperes. This also how much it supplies, 25 amperes. But what is the average value of switch current? Second method, you also solve like this. The average value of switch current equal to D into IL average. This formula you know. But IL, in the case of buck regulator, IL average equal to I naught average. What is the duty cycle? 0.5. What is IL average? 25. How much we can get? 12.5 amperes we can get. Like this also we can solve. Understood? Two buck regulators are connected in parallel means the resultant current equal to sum of the two currents. This is 25, this is also 25 amperes. But I want average switch current. Average switch current equal D into IL average. IL average is nothing but I naught average because it's a buck regulator. That is how much? 25. 0.5 and 25 means 12.5 amperes. Like that also we can solve. Clear? Okay. This about in detail what is the classroom workbook questions based on types of choppers, commutation method, SMPS and multi-phase choppers. Okay. With this, with respect to any commutative point of view, the DC to DC converters are completed. Okay. For any commutative point of view, whatever the theory points I given, that you concentrate, and whatever the problems I solved, that also you concentrate. The first concept I explained, types of choppers based on the output voltage level. That is buck regulator, boost regulator, buck boost regulator. The next concept I explained, types of choppers based on the quadrant operation. And steady state analysis of type A chopper, and based on that classroom workbook questions also I solved. The third concept I explained, commutation methods and types of choppers based on commutation. What is the concept of LC circuit, that I discussed. Okay, then I given what is the AC chopper, what is the multi-phase chopper, what is the SMPS also I given. Based on all this I solve the classroom workbook questions. Okay, with this the DC converter concepts with respect to any commutative point of view is completed. Okay, thank you. The next session will continue.